Thank you, Filippo. Good morning, everyone. Unfortunately, I cannot show my webcam, but I will be guiding you through a description of the legal knowledge graph, which is, let's say, an integral part of Lynx, and it has some architectural interactions with the components that Filippo has just described. So, in the first slide. The next slide, please. Yes, thanks. So the legal knowledge graph, let's say it's a collection of statements about the documents which are organized in Lynx, and which are these statements and these documents are used to satisfy the different use cases. So these documents come from different sources, and the statements some of them are, or most of them are produced by the different microservices that were mentioned earlier and that will be detailed in the next webinar also. The ontology that is the basis of this knowledge graph is one can think of it as a data model that is used for information exchange between the Lynx services. So on one layer of the protocol, let's say everything, all communication is through REST APIs, so using HTTP protocol, but the messages exchanged between these services are encoded in some specific format, which is described by this ontology. So, and they're at the end of the day expressed in JSON LD, but the specific schema of this JSON LDs has to do with the ontology. And so this ontology is, let's say, the organization of the legal knowledge graph on the one hand, and on the other hand, it serves as the interchange format between the different services. It is based on the NLP interchange format version 2.1, and we have also developed a couple of Chackle shapes, which are descriptions of rules that can be used to validate that this legal knowledge graph is compliant with the ontology, and that the messages being exchanged are indeed compliant with this. So in the next slide, please. Okay, we can see let's say the interaction of this legal knowledge graph. So with the rest of the Lynx platform. So the statements that make up the legal knowledge graph come from a variety of sources, which are the different annotation services produced by Lynx and that make part of the Lynx platform. And another source are control vocabularies that are used to annotate these documents, to classify them, for example, categorize them. And these control vocabularies are managed by an instance of Pool Party Semantic Suite, which helps in a user-friendly manner to manage these vocabularies. And these are also an integral part of the legal knowledge graph. These statements are served later by the document manager on the left-hand side, and these statements are actually used to power the different services and applications of the Lynx platform. In the next slide, please. This legal knowledge graph, as was mentioned, is based on NIF 2.1 ontology, and as such, its focus is on describing annotations on documents, but it is also interlinked with the LE ontology, which allows for describing the structure of documents and also its legislative related metadata. And it also links with the simple knowledge organization systems COS ontology, which allows to organize the different tags and concepts that can be ascribed to a particular document. In the next slide, please. Yeah, so as mentioned earlier, this legal knowledge graph is served by the document manager to power the different services and use case pilots in Lynx. And this use of statements and documents for services is kept synchronized by this document manager. And I will go a little bit later into detail about this. Yes, so this would be all from the legal knowledge graph point of view. And yeah, I will now leave the floor to Sotiris also from Semantic Web Company.
Good morning. My name is Sotiris Karambatakis, and I'm a senior researcher at Semantic Web Company. This is the last section of the presentation. Here we will describe the services that compose the Lynx basic platform. These services have to be considered as the foundational components of the Lynx platform, and they have a key role in the Lynx architecture. On the next slide, we can see the different basic components. These are the workflow manager, the document manager, and the authentication and identity manager. On the next slide, we can focus on the workflow manager. The workflow manager implements an API to instantiate the workflows and to monitor their instances. It is based on the Camunda technology. Camunda BPM is a lightweight Java-based framework. It can be used as a standalone process engine server or embedded inside custom Java applications. It offers non-Java developers a REST API and dedicated client libraries in order to build applications connected to a remote workflow engine. As you can see on the bottom of this slide, there are different endpoints offered by the workflow manager. One is grouped for tags, and the other is about instances. Tags can be think of a group of several workflow instances, so then you can actually query their status altogether or delete them and see the status of how much they have progressed in the engine and so on. The endpoint about instances, you can then instantiate a new workflow instance, define different parameters in order to modify its execution, check its status, and delete it again. This will be also demonstrated on the last on the demonstration of the platform we will see on the end of this presentation. BPMN is an abbreviation for Business Process Model and Notation. It is a graphical representation. Elena, can we move on to the next slide, please? It is a graphical representation that is used, thank you very much, that is used to specify business processes in a business process model. It is based on a flowcharting technique very similar to what you have in your mind by UML. BPMN has been designed to provide a standard notation readily understandable by all business stakeholders. Typically, this includes business analysts, technical developers, and business managers. BPMN can therefore be used to support common aim of all stakeholders on a project by adopting a common language to describe processes. On the next slide, we can see the population workflow we have defined for the Lynx platform. You can read this workflow from left to right. This is already described in BPMN 2.0. As you can see on the left side, the adherence point to the workflow is where you define the document, where you actually input the document into the workflow manager. This document has to be described in the data model that Victor described before. You just simply have to define the text of the document, some metadata about the document, and possibly some structured definitions of how the different sections and paragraphs of the document are structured in the document. Next, on the top of no, I'm still on the previous slide, Elena. Thank you. On this workflow, you can see on the top that there are different translation services and different annotation services. So in order to modify this workflow, you have just to define which of these services you want to use. After these services have finished their execution, all these executions happen asynchronously, then we have to gather all the outputs and merge all the outputs into one single document. This happens on the step after the big block over the left. And the next step is to store this document into some document manager. For this, you have to define the collection IDs and the document ID of the document to be stored. The last step for this workflow is to store this document into some indexing, so you can then use the indexing service to retrieve the document. This ends the workflow, and as you can see, this is very easy to modify and define if the use case is something different, with different requirements, let's say, and do any modifications on this. On the next slide, we can see the internals of the workflow manager. The client applications usually have only access to the workflow manager API, so the rest are orchestrated and managed by the workflow manager. The client application uses the endpoint we saw before, and then everything is managed from the workflow manager. So the workflow manager is responsible to route all these different requests for annotation services through the Camunda engine as it is defined on the workflow. Camunda internally uses also a database to store the definitions of the workflows, different parameters that can modify the execution of the workflow, historical data about previous executions, and so on. Additionally, it uses a service to store the documents because, as we said, all these different annotation services are working asynchronously. So one annotation service might end up earlier than a previous one. And then we need to somehow store these outputs into a cache. And in the end, all these are merged into a single document. So this is the basics of the workflow manager. On the next slide, we will see the document manager, which Victor will describe.
Thank you. So the document manager in the Lynx platform serves the purpose of storing documents, but also keeping them synchronized with their metadata. So the document manager is based on the Lynx data platform specification, and it consists of a thin REST API wrapping this Lynx data platform, one Lynx data platform implementation in particular called Trellis LDP. The metadata about the documents, along with other statements which constitute the legal knowledge graph, are also stored in Jena Fuseki triple store. The document manager is also in charge of taking care that documents are compliant with the ontology, so doing some sort of data validation, and also making sure that they can be processed by other services. So let's say the Lynx data platform implementation, which is underlying, or any Lynx data platform implementations, is very flexible in that it allows for, let's say, arbitrary documents and the metadata about these documents to be stored. But the document manager imposes some extra requirements on this to make the documents and their metadata much more usable by the other services. And yeah, in the next slide, Sotiris will talk to us a bit more about authorization and identity.
Thank you, Victor. Last but not least, the last component of the basic platform services of Lynx is the authorization and identity service. This implements an interface to manage the different digital identities, which is the clients and user accounts. And then you can also define different authorization rules. Let's say different access rules for the resources of the platform, different policies, and different permissions for each resource. Since authorization is centralized, the resources need to be synchronized with other microservices. The synchronization then is operated by the API manager. It acts also as an authorization server of the OpenAuth 2.0 protocol. On the next slide, we can see the core concepts of the Cloak implementation. We are using Cloak for all this management of resources and authorization. As you can see, Cloak can offer different identity providers, namely OpenID, SAML, or different login, social login applications such as GitHub or Facebook and so on providers. And from this interface, you can define all the different roles, the access to services, annotation services, and so on. On the slide that Filippo mentioned earlier, as you can, the typical use case is that we might have two different users of the platform, and we need to restrict access into some collection. So everything is managed through this. The very critical point on this authorization manager is that it never reaches the actual service. The API manager it acts as a gateway, so even before the request reaches the annotation service, it is authorized. So the developers of the annotation services or any other service on the platform does not have to care about authorization. This is all managed by Cloak and the API manager. This concludes the presentation about the basic platform components of the Lynx platform. Next, we can see the demonstration of the basic platform. In this, we will see how we can instantiate a new workflow instance to check how the authorization works and check the status of our workflow. In the end, we will see how we can get the document from the document manager. If you can, Thomas, start the demonstration. Thank you.
This is a demonstration of the Lynx platform services. You can find all of the available services if you go on our website, then click on Resources and Services APIs. Here you can see all of the available APIs. The basic platform services are the Workflow Manager, the Document Manager, and the Authentication and Identity Manager. We will use the Postman client to make all the requests today for the demonstration. You can easily import all of the specifications of the APIs in Postman by using the import function and then import the link here of its specific service API. I have already imported the APIs for the Document Manager and the Workflow Manager. The Workflow Manager offers two endpoints. One is about instances and the other is about tags. Let's now create a new population workflow instance. This is a post request. You need to define some parameters to modify the population workflow, and you need also to provide some input for the body of the request. This is actually the Lynx document that we will use for this demonstration. As you can see, this is a JSON file. It contains different metadata that describe the document. It also defines some parts on the text, which is actually the paragraphs or different sections of the document. And here is the text. As you can see, the text is in Dutch. On the top of the document, we can see the metadata of the document. This looks like a single JSON file, but in fact it is a JSON LD. It is RDF. Next, we need to define the parameters of the call. Here you can see all the different parameters you can define. The first one is called Document Platform. Here you can define the different document platforms that you want to use in order to store the document. For the demonstration, we will use the LDP implementation. As you can see, I'm using environment variables and this is set to be LDP. Next, we need to define the collection ID. This is set to be webinar. For the demonstration, we do not want to index this document into the search service, but we want to use the entity linking service. For this, we need to provide the entity linking project ID. This is the ID of the consent scheme we want to use in order to annotate our text. We need also to provide some
ID of the model that we will use to translate the text from Dutch to English. For this, I need to check out this. We do not want translation to other languages, just in English, and I need to provide the model. Here you can see the idea of the translation model. There exist different models for that map input language to output language. We do not want to use other annotation services, just the entity linking one. So I am also switching off this. And we set the tag to be webinar again, so we can check its status later. This is set to be webinar again. So now I'm ready to execute the call. I click on send, and as you can see, my request was rejected because I was not logged in the platform. The response was 403 forbidden access. So for this I need to be authorized. I go on this collection and I just use the key Cloak to get a new token. As you can see, all these parameters are already pre-filled by the OpenAPI specification of the call, and I just need to log in. I get a new access token. I need to provide my credentials. So now I got the token and I will use it for the call. Here I also need to specify the token. As you can see, I can just use to inherit the auth from parent. So if I click on send, you can see that my request was accepted. I got the workflow instance ID, which I will save to use it later. And we get also the document ID, which I will also use. So now we can check the population workflow. We should go on this request. It is a GET request. The only thing we need to provide is the workflow instance ID. If I click on send, I get the response, and we see that this population workflow instance has already completed. If there was any error during the execution, this would be reported here. Now I will switch to the document manager. I will open this API, and as you can see, the Document Manager API offers 3 different endpoints, one for collections, one for documents, and one for annotations, where you can actually do different CRUD operations on each of these instances. So here I just want to get the document that we ingested before with the population workflow. There is this endpoint about documents where I can get to retrieve the existing document. So this is just a GET request. I need to provide the collection ID, which is set as before in webinar, and also the document ID, which is also the ID that we got from the population workflow. This is actually the URI of the document, so it is the ID that you will see on the RDF representation of the document. If I click on send, I get a 403 forbidden because I have no access to this. But if I log in, I will use again key Cloak for this and get a new access token. So now redo the request, and as you can see, I can now access the document. This is in RDF in turtle representation. And as you can see, there are already annotations from the entity linking service. You can get the document in other serialization as well if you define a different header in the accept content header. So here we can define this to be application LD plus JSON or simply JSON. It's equivalent for our service. And you will get this document into JSON LD. Here you can see it is the same document we had before, but this time it contains also annotations from the entity linking service and the translation from the translation service.
Here are the annotations that were produced by the entity linking service. It found about 26 different annotations on the document, and here we can see also the translation that was produced by the translation service. It is in English. Thank you for watching this demonstration.